السلام عليكم يعطيكم العافية شباب. احنا اليوم في lecture 19. Okay, we are still talking about effective stress concept, the revolution of Terzaghi, right? Terzaghi, still remember his name? Famous Terzaghi, Carl Terzaghi. What is his nationality? Okay, good. We are trying to prove Terzaghi's revolution, Terzaghi's idea. Okay? Terzaghi's idea. We said that we will take three conditions. The first condition we discussed was the no seepage condition. Okay? No seepage condition. So we have water at height H1 and soil at height H2 below the water, and at depth Z we have point, we call it A, B, C and D. The valve is closed. Then no seepage, no water flow. And then we drew the stresses, right? At point A we had three zeros, right? Here we had H1 gamma water. Here we have H1 gamma water. Here we have 0, right? Okay. Now, when we continued, we have here H1 gamma water plus Z gamma saturated. Here we have H1 plus Z gamma water. And by subtraction, you remember, we did this arithmetically, right? We did some math here. We found that this will be equal to Z gamma prime, right? Gamma effective, right? If we continued, then we have H1 plus H1 gamma water, plus H2 gamma saturated. Here we will continue to have H1 plus H2 gamma water. And here we will have H gamma effective, right? We have this in front of you. I told you to have just 1/3 of the page and draw it, right? You did. 1/3. Okay. This is the same thing that we have here. Okay. Now we will move to the second condition. The second condition, that we have downward seepage. This is open, as you see. Open. We still have water inside. Then water will go out from the soil. Then we have downward seepage. Seepage down. Okay. Downward seepage. In this case, when we have downward seepage, of course, this is, as we said, H1, and this is H2, right? And this is point A, B, C at depth Z, and D, right? A, B, C, D. Now, we explained that once we have downward seepage, then point B will hold the water to H1, which is different than H1, previous H1, right? Remember, guys, H1 here is not H1 there in the previous example, okay? But point B will raise the water to a height of H1, okay, whatever H1 is. Now, in the soil was able to hold water from this point, for example, to here. But now once we have additional force, then it will not be able to hold it to here. It will hold it to somewhere below that line, okay? So it will hold it, if we have water in blue, so water will be here. You see? This is water, right? And then water here will be to a height less than what we had before. And this is You see? Point B, hold the water to a height of h1. Point C cannot hold the water to that height because there is additional stress. So it will hold it to that point, okay? Which is at distance, I called it IZ. Okay, this is IZ. Okay, and then at D, it hold it to a height with distance of h. Okay, now I try to explain to you why I get it IZ. Okay, let me explain it again this time. Okay, at point B, water was risen to this point, right? So this is, let us call it 0, 0 elevation. Okay? We will count from it. So this is 0, 0 elevation. Now, as we go down, as Z increases from 0 to how much? To H2, you see? As we move from B to D, as point C moves from B to D, which means that from Z equals to 0 to Z equals to H2. Are you with me? Okay? Concentrate, please. As point C moves from here, point C equals 0, right? Z equals 0. And then Z increases until we reach maximum Z. Maximum Z equals to H2, right? As we move down, water will move down from 0, 0 to reach this distance, which is h. Okay? This is a gradual decrease. Gradual decrease, right? It began with 0, 0. Now it is below 0, 0 by h. Okay? So any place here depends at z, right? Depends on z. Means when z equals to 0, we have 0, 0, right? When z equals to h2, then we have h, right? So the distance that water will flow through is maximum h2, right? And at that time, the difference in level will be complete h, right? Sorry, complete h. Right? It will be complete h. Again, when z equals to 0 at point B, okay, the level will be 0, 0, right? Say yes or no. And be sure when you answer. Okay? When z equals to 0, it means at point B, the level will be 0, 0. When z equals to the maximum of z is h2, right? At point D, right? The whole difference will be h small, right? And anything between them, it will be part of h. Part of h, right? Part of h. Now, the maximum distance that z will go, or the distance that z will go, is from 0 to h2, right? And at that time, the difference in level will be from 0 to maximum h, which is h minus 0h, right? Right? Okay. Now, we know that I equals to delta h by L, right? Delta h is the level difference, and L is the distance that the water flew through, right? So, delta h maximum equals here what? It equals h, right? And L is h2, and that is function of z, right? Function of z. Now I will concentrate on this. Forget this. H over h2 multiplied by z. Now let us see. When z equals to 0, this equation will be 0. I mean the level will be 0. Is it correct? Okay, when z maximum is how much? h2, then the distance will be h, right? So mathematics says right? By mathematics, it's right. By logic, it's right. Again, when z equals to 0, then mathematics says that this will be all 0. Right, it's 0. Okay? When z equals maximum h2, then this will be h. Right, h. You see? So anywhere I can say that h over h2 by z, but h over h2 is I, right? So I can say that this is equals, at any point it's equals to iz. You just give me z, and I'll give you everything else. iz. That's why I wrote it here, iz. And now let me explain to you what does it mean. Now, iz, okay? When z equals to 0, iz is 0. When z equals to h2, it will be h, right? Anywhere in between, for example, suppose the h2 is 4 meters. h2 is 4 meters. So look at here, h over h2, which is 4 meters, right? Now, at z equals to 0, 0. At z equals to 1 meter, 1/4 h, right? When z equals to 2 meters, half h. When z equals to 3 meters, 3/4 h. When z equals to 4 meters, h. You see? So iz, I put iz. Now we understand why I put iz. Okay? Let me erase all this. What else here? Now, knowing this, let me also take this away. Now, we call this H1, right? And this H2. And this point is D, right? Now, look at me. Please concentrate. We will count again. We will find stresses. At point A, what is sigma? Total stress. At point A, what is sigma? 0. There is nothing above A, so it's 0. What about U? Pure water pressure. No water above it. Okay. What about then effective? Of course, no submerged soil above it. Okay. We go to point B. Point B. What is sigma? The weight of water. H1 multiplied by gamma water. What is pure water pressure? Then what is pure water effective stress? And it is obvious. It should be 0. It should be 0 because there is no soil submerged in water above it. Now let us go to point C. Point C, what is stress? Point C. H1 gamma water plus Z gamma saturated. Okay. What is pure water pressure? Pure water pressure, remember, is the height of water above sea. What is the height of water above sea? What it is? H1 gamma water plus Z gamma water minus IZ gamma water. Remember? This small portion. We call it IZ, right? So it's H1 gamma water plus Z gamma water minus IZ gamma water, right? Okay, so we write it here. H1 plus Z gamma water minus IZ gamma water. Now the effective stress, and I will write here, guys. Look. I raised it up that you will see. Let me use this. Okay. Now mathematics. H1 gamma water, right? Are you with me? Are you with me? Plus Z gamma saturated, right? Minus H1 gamma water, right? Minus Z gamma water, right? Minus IZ gamma water. Okay, this will go, right? I will have here what? Z gamma prime, right? Minus IZ gamma water plus. Plus. That's right. Then what we'll have here? Z gamma prime plus IZ gamma water. And look, actually this is the same. I just subtracted IZ gamma water here, so I added it here because the sum of them will be the same, right? So I took IZ gamma water, I added it here, IZ gamma water. By the same way, we can say that here it's H1 gamma water plus H2 gamma saturated, right? And here H1 plus H2 minus H multiplied by gamma water. And here it will be H2 gamma effective plus H gamma water, right? Now, take the second 1/3 of the page and draw this. This is downward seepage, okay? Please, quickly, draw this, quickly. Write everything, draw everything very quickly. And this is the second condition, which is downward seepage. Downward seepage. طيب يا شباب انتبهوا هلا قدامكم رسمتين. انا مش للاسف مش راح اقدر احط الرسمتين هلا قدامي على الكمبيوتر، وراح اروح للرسمه الثالثه. شو هي الرسمه الثالثه؟ upward seepage. upward seepage. المره هاي يا شباب شو عملنا احنا؟ طلعوا شو عملنا؟ ضخينا المي من تحت، حطينا بربيش مي، ضخينا المي من تحت، بلشت المي تطلع وين؟ في التربه، وبعدين تطلع من فوق تتشقلب من الجهه الثانيه. صار في عندي ايه؟ upward seepage. Upward seepage. Remember guys, this is H1, right? And this is H2, and this is Z, and this is point A, B, C, and D. Now, point D was holding all this water, right? And now, additional person came with her and began to hold with her. Then, this point can hold water to higher distance, right? To higher distance. Because there is additional energy, right? يعني أجا مين يحمل مع النقطة دي. فصار عندها قدرة تحمل المي أكثر. عشان هيك إذا بتلاحظوا point D, we have water to this level, which is H, right? H above the 0, 0. Point C, as we go up, soil will prevent us from doing so. So it will decrease our effort. Okay? So water will be to this distance. This distance is, I call it IZ. The same idea I explained before, right? Until we reach B, B hold it to H1. H1 here is not H1 before, it's not H1 in the previous, okay? H1. Okay, it's not, don't just put in your mind that this H1 is the H1 that we had in the downward seepage or the H1 that we had in no seepage, right? So, B will hold the water to this point 0, 0, right? D will hold the water to H above. Anywhere in between them, it will be IZ. Okay? Clear? Okay. Now, let us draw stresses. At point A, 3 zeros, right? At point B, H1 gamma water, and here H1 gamma water, and here 0. At point C, H1 gamma water plus Z gamma saturated. Here H1 plus Z plus or gamma water plus IZ gamma water, right? We added IZ gamma water. We added. In the previous example, we subtracted. Here we added, right? So if we do math, H1 gamma water minus H1 gamma water, cancel. Z gamma saturated minus Z gamma water, it's Z gamma effective. Okay? Z gamma effective. Then minus IZ gamma water. Z gamma effective minus IZ gamma water. Here we added IZ gamma water. Here we subtracted it. It's the opposite that we had in the previous. Okay? Now, this will continue to be like this. H1 gamma water plus H2 gamma saturated, right? And here it will be H1 plus H2 plus H gamma water. And here we will have, what we will have? H gamma prime minus, no, H2 gamma prime, right? Minus H gamma gamma water. Okay. H1 gamma water. يلا ارسموا الرسمة في الجزء الأخير. أي قصدك؟ ثانية H2 في gamma prime minus H1 H صح. H gamma water. ماشي يا شباب، نرسمهم بسرعة. Now we have three drawings. We have three conditions. No seepage, upward seepage, downward seepage, right? And why we did so? Why we did so? Guys, why we did so? We wanted to prove if Terzaghi was correct or not, right? Because if we prove that Terzaghi is okay, he's correct, then we will use effective stress from now on. If Terzaghi was wrong, so we will forget his name, from which nationality he is, what is his first name, if he was married or not, if he has children or not. We will forget everything about him. Okay? Is he correct or not? We will see now if he is correct or not. You just try to finish the third drawing quickly. Are you done? You have three drawings in your page. Terzaghi is okay. Is he right or wrong? Who's still writing? Finish. Yeah. Who's still writing? You too? Finish. Okay. Let us see. You have the three drawings in front of you, but I will go back. to the first drawing. The first drawing. Let us look at total stress. At total stress. At A we have 0, right? At B we have H1 gamma water, then we have at C H1 gamma water plus Z gamma saturated, then we have H1 gamma water plus H2 gamma saturated, right? Now, when we have downward seepage, is there any change? Same values? Same values? Same values. 0, H1 gamma water plus Z gamma saturated, H1 gamma water plus H2 gamma water. It's the same. Okay. What about upward seepage? The same thing. So, you see, if no students in the class, or all students in the class, or some of the students on the class, it's the same thing. Is it reasonable? Is it reasonable? How come? If no seepage, or downward seepage, or upward seepage, the total stress is the same. So does it represent any change? It doesn't represent changes. Is it okay then to deal with it? It doesn't show any changes. ما في أي مشكلة. كان في عندي upward seepage, downward seepage, no seepage. النتيجة نفس الشيء. The result is the same. إذن هي لا تظهر ولا بتعطيني أي اعتبار لأي تغير في المي. معقول التربة زي ما هي إذا كان حطينا ضخ من تحت لفوق أو من ضخ من فوق لتحت أو ما فيش ضخ نفس النتائج نفس الاسترس؟ معقول هذا الكلام؟ مش معقول بس هيك طلع معي. إذن total stress is not good to use. It's not good to use total stress. What we have to use? Let us go back and see where is the change. Okay? I will not look at poor water pressure. Let us look at the effective stress. It was 0, 0, Z gamma prime, H gamma prime. Right? Remember. 0, 0, Z gamma prime plus. Okay? So when we had downward seepage, we had some additional stresses. When we had upward seepage, we subtracted some stresses. So who represent reality? Who represented reality here? The effective or the total? So we have to deal with effective or with the total. The total says no students, all students, some of the students, they are the same. You have to pay the same ticket. But here it says, if the bus is complete, then you pay 100 shekels. If nobody in the bus, then you pay nothing. If 50, then you pay 50. Right? So who represents the reality? Effective stress or total stress? So we will deal with, so Terzaghi should remain the father of soil mechanics. And we should still remember his name. And from now on, we will deal only with effective stress because it is the value that represents the reality. No seepage is not like downward seepage. It's not like upward seepage. So we cannot deal with them as if there is no change. كأن شيئا لم يكن وبراءة الأطفال في عينيه. مو هيك الشاعر بيقول؟ لا. Upward seepage is different than downward seepage, is different than no seepage, and unfortunately effective stress doesn't represent this. So from the time Terzaghi said this, we stopped dealing with the total stress, and we are dealing with effective stress. We are convinced. Are you? Are you convinced? Yes or no? You don't know what's convinced? Convinced. مقتنعين?
Yes.
In Arabic, okay. Everybody is convinced. In English, it's difficult. We will deal with effective stress because Terzaghi is okay. Now, just one question. Let me ask you. Okay? Let us go back to the first drawing. Here. Okay? At point C. At point C. Z gamma prime. Right? Z gamma prime. Gamma prime is gamma saturated minus gamma water. Right? Z gamma prime. Can Z gamma prime equals to 0? No, because Z is a distance. Okay? and gamma saturated gamma water is not 0. So no, it cannot be. Let us go to this. Z gamma prime plus Iz gamma water. Can it be 0? Can it be 0? No, because if this cannot be 0 and we add it to it, so it cannot be 0, right? It cannot be 0. Okay. What about this? Z gamma prime minus Iz gamma water. Can it be 0? Okay. So, if they were equal, then it will be 0. If they were equal. If they were equal mathematically, if they were equal, then subtraction will be 0, right?